Hello, everyone. We're the CMI team, and our project is efficient resources management in shipping, optimizing time and fuel consumption. We work with CMMI. It's an amazing institute who aims to foster blue growth, and our goal is to alleviate port congestion and therefore minimize the fuel consumption. In this project, we mainly use the AIS data. It contains the dynamic data and static data for ships. And what we are going to do is to use this AIS data to build our model, and therefore we can give suggestions to the coming ships.
So first of all, our methodology, we calculated 3 different congestion indicators using positional data. These were spatial density, spatial complexity, and the average time in the port, based on assigned polygons that we calculated using an algorithm for the port and the anchorage. These are calculated on a weekly basis and then are applied scores of low or high congestion. These outputs are then used as model inputs along with a couple more inputs from the AIS data directly that determine for any given ship whether it will be above or below the global average for service time for that specific port.
The correlation matrix indicates our selection of features is reasonable. Basically, we use 4 types of classification model, and SBM model performs the best. It has the highest value for F1 score, precision, and recall. The confusion matrix also shows that all the models can predict the negative class well.
Based on the results from our congestion identifiers and our classification model, we can make recommendations based on the expected service time, the ability to moor at a port, and the ships currently waiting at anchorage. This gives us 7 different scenarios that a ship could find itself in, and based on whether they're above or below the average, decisions that they can make and how to approach queuing at the port. In terms of the risks and barriers that we faced during the project, we had limited data availability, specifically referencing navigational status and destination. We also had few decision variables when building the model, as well as computing power to work with the large amount of data that we had. We also had limited control over port operations. In terms of our recommendations, improving the current model would require improved collection process for the AIS data, as well as specific ship information regarding cargo and shipping contracts, any information regarding port operations, staffing, or equipment present in the port, as well as optimized port layouts specific to each type of port that we're analyzing.
So the expected benefits with our current result is reduce the total wait time for income ships, reduce the fuel consumption, operational expense, and the pollution. And with our recommendations, improve the conditions of moor and anchor ship, improve ship loading and unloading techniques, and reduce service time and fuel consumption further. And the implementation plan is use the AIS data with standardized navigation status and the destination value. Allow ports to access ship cargo information and contract regarding priority service, improve allocation of equipment and personnel with standardized hours of operation. And the last one is optimize facility layout for ship service station. And that's all. Thank you.
Thank you for your time.